Hello friends, in this video we are going to study about the mathematical modeling of electrical systems. The electrical systems, they consist of three basic elements: a resistor, inductor and capacitor. Let us first study the first basic element of the electrical system, resistor. Let us consider an electrical circuit having a resistor in it. This resistor is having the resistance R, and the voltage applied across this circuit, it is E, and the current flowing through this resistor is I. Now this resistor is having the resistance as R and the unit of resistance is ohm. Now the current flowing through this resistance, it is given as I and the voltage is E. So the relationship between this voltage drop across the resistor and the current, it is defined by the Ohm's law. So according to Ohm's law, E, that is the voltage drop across the resistor R, is equals to I, the current, multiplied with the resistance R. So it is the relationship between the voltage drop and the current flowing through the resistor. Okay. So this is how, or this is the mathematical expression defining the element resistor. Now let us study the second element, inductor. Inductor is, we will define inductance . So inductance is defined as the flux linkage per unit current. So L, let's denote this inductance by L, and L is equals to d phi by dt. Okay, that is phi, it is given, it is the flux, and let us draw the circuit for it. It is an inductor having the inductance L, and I is the current flowing through it, and E is the voltage applied across its terminals. So if we write the voltage drop across the inductance, it will be given by E equals to L di by dt. Okay, or we can write I, it is equal to, L will come this side, so it will be 1 by L integration E dt. So it is the relationship between the current and the voltage drop across the inductance, and in this way we can represent an inductor in an electrical system. Okay. Now let us study the third element, capacitor. Let us first draw the circuit for it. This is a capacitor having the capacitance C, and E is the voltage applied across its terminals, and I is the current. So this capacitance, it is defined as So capacitance is defined as the ratio of the charge on the capacitor to the voltage across the capacitor terminals. So if we write it, we will get the formula for it as capacitor. It is the ratio of the charge, that is Q, to the voltage, that is E. So C is the capacitance and it is equal to Q by E. Now Q, it is equal to CE, okay, and if we write the value of E, we will get 1 by C, and Q, it is equal to the current, it is equal to dQ by dt, okay. So Q will be equals to integration of I dt, okay. So putting here the value of Q, we will get integration I dt, or if we write the relationship in terms of I, it will be C dE by dt. So these are the two equations. One is for the voltage across the capacitor and second is for the current across the capacitor. So in this way we can represent a capacitor in an electrical system. And this capacitance is having the unit as farad. Okay. Now let us consider a circuit, an electrical system, and first we will consider an electrical system which is having the series combination of these three elements: resistor, inductor and capacitor. After that we will study another electrical circuit which is having the parallel combination of these three basic elements. So let us first study the series combination of the resistor, inductor and capacitor. This is the circuit diagram of an electrical system having the series combination of resistor R, having the resistance R, and inductor having the inductance as L, and a capacitor having the capacitance as C. These three elements, they are connected to a voltage supply giving the voltage E, and the current flowing through this circuit is IT. So let us write the equation for this electrical system. We will apply KVL, that is Kirchhoff's voltage law, for this circuit. So we will get that the sum of the voltages in this loop is equal to the 0. So first start from here, we will have E minus because in this we are having the reduction of voltage here. So according to KVL, it will be minus. The voltage drop across the resistor will be RIT. We have already studied it when we studied the element resistor. So it is given by RIT. Then minus L DIT by dt minus 1 upon C integration I dt. And the sum of these voltages, algebraic sum, it will be equal to 0. Okay, this is the voltage drop across the element resistor. It is across the inductor, and it is the voltage drop across the capacitor. So the algebraic sum of all these voltages in a loop, it will be equal to 0. So if we shift these three terms to the right hand side, we will get okay. So this is the equation which we have obtained. Now we know that the current, it is equal to dq by dt. Okay, that is the differentiation of the charge with respect to time. So putting here the value of I, we will get E equals to R. So this is the equation in which we have replaced the current with the charge, and we have put the value of current in respect of charge, and we have found out the relationship between the voltage and the charge across the elements. Okay, so this is the final equation, or we can say that it is the mathematical model of an electrical system which is having the series combination of R, L and C. Now let us study the parallel combination of RLC and see that how we can derive its mathematical model. So this is an electrical system which is having the parallel combination of the three elements: resistor, inductor and capacitor. These three elements, they are connected to a current source giving the current as IT in the circuit. So this current will be divided in these three elements, and we will have IR as the current flowing across the resistor R, and IL is the current flowing across the inductor, and IC is the current flowing across the capacitor. So let's write the equation for this. First, we will write the equation according to the Kirchhoff's current law, which states that the algebraic sum of the currents at a node, it is equal to 0. So in this, we will have IT equals to, because IT is divided into these three currents, so it will be equal to IR plus IL plus IC. Okay. Or if we write the values individually for IR, let us see what is IR. IR is the voltage across the resistor E divided by the resistance R. And for IL, that is the current across the inductor, we will have 1 upon L integration E dt. And IC will be C dE by dt. We have already derived these equations earlier when we have studied these three elements. So we will substitute the values of these currents IR, IL and IC in this equation. We will get IT equals to E by R plus okay, so this is the equation which is showing the relationship between the current in the circuit and the voltage, and these three elements are L and C. Now if we put the value of the voltage E, it is in terms of flux, it is d phi by dt, where phi is the flux. So putting the value of E in this equation, we will get IT equals to, E is what, d phi by dt, so it will be 1 by R d phi by dt plus 1 by L. Integration of d phi by dt with respect to dt, it will be phi plus C dE by dt, it will be d2 phi by dt square. So we have got the relationship between the current and the flux, and this is the mathematical model or mathematical representation of the electrical system having the parallel combination of the three elements R, L and C. So in this video, we have studied the mathematical modeling of two electrical systems. First electrical system is having the series combination of RLC, and second electrical system is having the parallel combination of R, L and C. I hope you have clearly understood this topic. Thank you.